Hello, viewers, and welcome to Group 1 TV, where in science we trust. I am Glycyl C. Jumalon.
Alrich, Joanne, and Bisnar.
Cesar under Gonzales.
Jed Stanley Pancho.
Miko Angelo C.
Melawati Ahmad.
Joanne F. D. Guzman.
Jezzel Ann B. Ramos.
Today, we are going to talk about practical applications of science in our lives. We have general biology, general chemistry, and general physics. Now, let's get started. Taxonomy. It is the science of classifying living things. It is the field of biology which deals with the nomenclature, identification, and classification of organisms. Taxonomists are responsible for identifying, classifying, and naming all these different species.
The trick of taxonomy is basically figuring out where all those branches of the evolutionary tree are, and finding some convenient labels to help us understand of these remarkable interrelationships.
To get that structure, biologists use the taxonomic system to classify all the organisms on the earth. We have the phylogenetic tree, or the tree of life that illustrates the evolutionary relationships between all living species. Then, the best way that scientists can draw the phylogenetic tree is by using cladistics. It involves identifying shared derived characteristics, while dichotomous key is a guide towards the final identification of an organism through several steps with two statements which describe certain characteristics.
Without a specific or unique name for the species, it is impossible to have a proper preference to that specific organism. By creating a system of naming organisms, confusion can be avoided. Thus, Carl Linnaeus is responsible for the formal introduction of the naming system into the scientific world, as established the practice of binomial nomenclature.
Binomial nomenclature is a system in which each species receives a name of two terms. The first one indicates the genus, and the second one is the species itself. This system is what scientists use as a uniform of naming new and uncommon types of animals, plants, protists, and any other organisms.
In the 18th century, Carl Linnaeus developed a system for classifying living things, which has been developed into the modern classification system. Linnaeus' system consists of hierarchy of groupings, called taxa, singular taxon. It uses 7 taxa, which are arranged in logical order: kingdom, phylum, class, order, family, genus, and species.
However, because there was a lot of life that Linnaeus had no idea about, there was a new taxon above the Linnaeus kingdom. It is called domain, the largest and the broadest category. The domains are bacteria, archaea, and eukarya.
Taxonomy is the way living beings are divided up into kingdom, phylum, class, order, family, genus, and species. A real-life application or example of it is the Dewey Decimal System, or the way libraries classify non-fiction books by divisions and subdivisions.
The Dewey Decimal System is a classification system used by libraries to arrange books by subject. Each book is issued a shelf mark number, usually found on the spine of the book, and arranged in numerical order. The 10 classification of Dewey Decimal System are general works, philosophy and psychology, religion, social sciences, language, natural sciences and mathematics, technology, the arts, literature and rhetoric, and history, biography, and geography.
Basically, taxonomy is the Dewey Decimal System of evolution.
Colligative properties are the physical changes that result from adding solute to a solvent. It depends on how many solute particles are present as well as the solvent amount, but they do not depend on the type of solute particles, although do depend on the type of solvent.
There are 4 colligative properties we will look at, which are vapor pressure lowering, boiling point elevation, freezing point depression, and osmotic pressure.
A liquid will always have a particular vapor pressure, since particles at the surface of the liquid can spontaneously enter the gas phase. The number of gaseous particles determines the vapor pressure, but solute particles sitting at the interface occupy some of the surface area, which hinders some solvent molecules from evaporating. Therefore, the presence of a solute causes the vapor pressure of a liquid to decrease.
A similar phenomenon is that of boiling point elevation. When a solution is raised to the temperature at which the solvent should boil, again, there are solute particles blocking the solvent molecules from going into the gas phase. This means more heat energy will be needed to compensate for this activity, which results in an elevated boiling point.
Freezing point depression is similar but deals with the interface between the liquid and the solid phases. For a liquid to freeze, it has to form a lattice. But the presence of solid particles interferes with the ability of the solvent particles to efficiently form the lattice. So to compensate the system, you'll have to reach an even lower temperature to freeze.
The osmotic pressure of a solution is a pressure of difference needed to stop the flow of solvent across a semi-permeable membrane. The osmotic pressure of a solution is proportional to the molar concentration of the solute particles in solution.
One of the four colligative properties is boiling point elevation. An example of boiling point elevation is cooking with salt. Salt is a wonderful ingredient in our kitchen. It not only adds flavor to our food, but also raises the water's boiling point.
The chemistry behind this is that when salt, sodium chloride, is added to water, it dissociates into sodium and chloride ions. These ions alter the intermolecular forces between water molecules. Also, even without charged solute, adding any solute to water raises its temperature because of boiling point elevation. The more salt you add, the more you are raising the boiling point because it depends on the number of particles formed in the solution as it is a colligative property.
Electricity is the presence and flow of electric charge.
To really understand electricity, we must go even further and look inside an atom. Everything in the universe is made up of atoms, which we can call the building blocks of everything. Atoms consist of protons and neutrons. These form the nucleus of the atom. Orbiting the nucleus are the electrons. It's these electrons that are responsible for electricity, hence the name.
Electricity can be a friend and a foe.
As a friend, it is always there bringing you comfort, convenience, and entertainment. Life would be harder without electricity, as people use it for lighting, heating, cooling, and refrigeration, and for operating appliances, computers, electronics, machinery, and public transportation systems.
However, if electricity, when improperly handled and taken for granted, can be a dangerous foe. It takes one old or poorly wired plug to prove how much damage can electricity bring.
Some of the dangers of electricity includes electric shock and form from contact with live parts, injury from exposure to arcing, fire from faulty electrical equipment or installations, and explosion caused by unsuitable electrical apparatus.
Electricity is a most helpful tool, but understanding how to work around it and use it safely is important. Today, we will learn about the different safety precautions in dealing with electricity in our everyday lives.
While electricity can be considered as man's best friend, it can also pose danger to the consumers if not handled properly. Here are some tips for using electricity safely.
Wire plugs properly and always fit the correct fuse. Never use wet hands or switch appliances off and on. Replace worn or damaged flexes and plugs. Avoid octopus connections. This draws more electricity than the wires are supposed to handle, causing the wires to overheat, which can then cause a fire.
Always keep safe while dealing with electricity.